welcome back to All This Math. This is Professor Parker, and we're doing some Praxis prep today, and we're going to be adding polynomials. All right. So let's take a look. Let's take a look at what we have. We have two quantities. We have two trinomials, right? They're called trinomials because they have 1, 2, 3 terms, and this also has 1, 2, 3 terms. Okay. So, and trinomials are a type of polynomial, similar to a binomial or a 4-term polynomial or a 5-term polynomial. These are just terms that we use to describe, what we're working with. All right. So we're basically going to be, because we're doing addition, right? There's a plus sign between these two expressions. We're basically going to be combining like terms. And you'll notice in a lot of these videos that I produce, I talk a lot about combining like terms because combining like terms is such a relevant aspect of, what we're doing. When we're doing algebra, we're combining like terms. And even in geometry, when you have to solve equations in geometry, you'll have to combine like terms, right? Combining like terms is something very important, and it's a standard, right? It's an integral part of any algebra, any, geometry, pre-calculus, trig, when we're solving problems in mathematics generally, right? We combine like terms. All right. Now, what we want to do is combine like terms between this expression and this expression. So we actually want to get rid of the parentheses first, right? But when you're doing addition, when you drop the parentheses, none of the terms change. The terms stay the same, and they're just rewritten without the parentheses. Now, if this was a minus sign and we were doing subtraction, then everything after the minus sign would take its opposite sign. So this 8n would become negative 8n. This 5n to the third would become negative 5n to the third. This 2n to the fourth would become negative 2n to the fourth if this were a minus sign instead, right? So it's all about where the minus sign. So if there's a minus sign, then the expression that immediately follows that minus sign, everything inside of it becomes its opposite, or becomes, well, if it's positive, it becomes negative. If it's already negative, it becomes positive. Now, I say the immediate because what immediately follows the subtraction sign, because let's say that we had an expression that had 3 expressions in it, like something minus something plus something else, right? Plus another trinomial. Everything, if this was a minus sign, then everything inside the parentheses would become its opposite. But if there was a plus sign after it and then another expression, then the terms inside the expression after that next plus sign would not become its opposite, because it's only about what immediately follows that minus sign, right? What's in the parentheses immediately after that minus sign. That's what matters, all right? That's what you change. But here, we're doing addition, all right? We're doing addition, so nothing changes. So I'm just going to rewrite the problem with no parentheses. And then after that, we're going to combine like terms. So we just write 7n plus 3n to the third plus 3 plus 8n plus 5n to the third plus 2n to the fourth. All right, so that's what we start out with, right? And then we're going to look for like terms. Now, this is like a game. I always thought this was fun, combining like terms. We're first looking for like terms. We first look for like terms, identify the like terms, and then the next step is to combine them by doing addition or subtraction. All right, so I see a 7n right here. Now, what are like terms? Like terms are numbers. Numbers, plain numbers or constants are all like terms. Positive numbers, negative numbers, fractions, decimals, big numbers, small numbers, they're all like terms. They can all be added and subtracted with each other with no problem. Now, in terms of variables, when we start talking about variables, like the letters, like n, right? The variables have to be the same variable with the same exponent in order to be considered like terms. The same variable, same exponent in order to be considered like terms. Again, same variable, same exponent. Even if there's a group of variables within a term, like let's say you have x, y, z. X, y, z is x to the first power, y to the first power, z to the first power. X, y, z is not the same as x squared, y squared, z squared, because even though those variables are the same, the exponents are different, right? So same variables, same exponents, and even if it's a group of variables, all right? So keep that in mind. So now I see 7n, 3n to the third is not alike. 3 is not alike. 8n is alike though. So 7n and 8n are like terms. So I want to identify them. So I'm going to underline both of these. That lets me know that these are both like terms because they got the same symbol underneath of them. I underline both of them. Then I look at 3n to the third. And I say, okay, well, I already know 7n is not alike. 3 is not alike because 3 doesn't have an n to the third with it. 8n is not alike, but 5n to the third is alike because I got n to the third and I got n to the third. Now, let's say you're wondering, okay, well, how is it a like term if that's a 3 and that's a 5? That's okay. The coefficient don't matter. When you try and determine if something is a like term, the coefficients don't matter. And that's what these numbers are called, coefficients. They call coefficients. They basically just tell you how many of the variable you have. So 3n to the third basically means you have 3 n to the thirds. So that would be n to the third plus n to the third plus n to the third. You got 3 of them, right? 3 times n to the third. And here you got 5 of them. But they're the same thing. You still talk about n cubes, n's cubed, right? So I'm going to identify them, put a check mark over top. And it don't matter what symbols you use. That's just my twist. I like using these symbols. I do underlines. I do check marks on top. I box some of them. I circle some of them. Sometimes I put like a little diagonal line to the side. I do a whole bunch of stuff. As long as I use symbols that I could readily recognize to know that they're like terms. It ain't that deep, right? So then I'll get to 3. And I say, okay, is there another number or constant? That's the technical term for a number, right? A constant, because it's constantly going to be that. It's not a variable. It's not going to change. This 3 is what it is. It ain't never going to be nothing more than a 3. And it ain't never going to be nothing less than a 3. It's just a 3. It is what it is, right? So is there a like term? This ain't alike, this ain't alike, and this ain't alike, right? So 3 is by itself. And that's cool. You don't have to have a like term. There's nothing wrong with that. It's not like we're going to be mad at the 3 or get rid of it because it don't have a like term. It don't have to have a like term. But if terms do have other like terms, you want to combine them. That's how we simplify the problem. So we don't have a whole bunch of terms that we don't need. We can just simplify by combining them together, right? What about this 2n to the fourth? 2n to the fourth don't have a like term because there's no other n to the fourth out of all these terms. There's no other n to the fourth. So 2n to the fourth is by itself. All right. Now, when I write my answer, all right, I'm going to write it in what's called descending order according to the exponent. Meaning I'm going to look for the term that's got the biggest exponent. The biggest exponent. In this case, it would be 2n to the fourth. And I'm going to write that first. Now, if you don't write it this way, that does not mean that your answer is wrong. But on the Praxis, it's more than likely that the answers, if it's multiple choice, will be written in that way and given in that way. So you might as well just, write it in the way that the multiple choice answers will be given to you, right? And also most textbooks do write answers in descending order according to the exponents. So I'm going to write 2n to the fourth first. And again, 2n to the fourth did not have a like term, so it was nothing to combine with it. So it's just 2n to the fourth. So I got 2n to the fourth power. And then I got 3n to the third, right? I got n to the third power, right? I got 3 of them, and then I got 5 of them. So if I combine those all together, that makes 8. That's 8n to the third, because it's positive 3n to the third and positive 5n to the third. So altogether, I got 8n to the third. So that's plus 8n to the third. All right. Then I don't have an n squared term because that naturally would come next. Because see how it's going 4, 3, but I don't have an n squared term. There's no n squared term up here. So we skip that. Then we go to the n to the first power, n to the first power term. So I got a 7n and I got an 8n, a 7n and an 8n. So 7n plus 8n is 15n. So we got 15n, right? 15n. And then, last but not least, we got this 3. 3 is a constant. Now, if you want to get kind of technical, we could think of it as 3n to the 0 power. N to the 0 power just becomes 1. So instead of you having 3 times n to the 0 power, you really got 3 times 1, which is just 3. But that's a little deeper than we need to worry about right now, right? So at the end, we just put plus 3. And this is the final answer. So this is the sum of this trinomial plus this trinomial. All right. So we dropped the parentheses, right? Identified our like terms. We combined our like terms. And we wrote our answer in standard form, which is basically in descending order according to the exponents. You know what I mean? All right. Now I've shown you how to do it, but the way you really learn this and really commit it to memory is by getting practice. So what I highly suggest you do is go find some examples that are similar to this online, some examples of addition and of subtraction. Remember, when you do subtraction, you have to change everything inside the parentheses following to its opposite. So again, just a recap of what I said earlier in the video. If this had been a minus sign, if it had been a minus sign, then this would, in order to drop the parentheses, what I would have did was basically multiply everything inside the parentheses by -1. So this 8n would have become -8n. This 5n cubed would have become -5n cubed. This 22 to the n to the fourth, let me say that again. This 2n to the fourth would have became -2n to the fourth. That's what happens when we're doing subtraction. And then we'd have all the terms written out, and then we would just combine, we would identify the like terms and then combine the like terms. So we follow the same steps in the process. We just had to do basically one additional step because we're doing subtraction. But when we add, all you really gotta do is just drop the parentheses. Because basically all you're doing is really doing, you multiplying +1 by each of these terms. And when you multiply +1 by something, nothing changes. So you can think about it that way. So, all right, so go online, find some practice problems, get some practice so you can master this, and you'll be ready for the Praxis. All right? And I'll catch up with you on the next video. Peace.